This is a model that relates five latent variables, which are job performance, JP, job satisfaction, organizational commitment, democratic management, and scarcity of comparable jobs. So, this model theorizes that democratic management at work would increase job satisfaction, which then would increase job performance. And this model also hypothesizes that scarcity of comparable jobs would lead to more organizational commitment, since if there are many jobs available, one would be more committed to the organization. That would lead to greater job performance. This model is based on data that was created in such a way that the model is correct, with one exception. This is a reciprocal relationship. And the data was created so that there is only one reciprocal relationship here, and that's this one here between JS and OC. So let's assess this reciprocal relationship. Um, First thing that I need to do, and even without a reciprocal relationship, I would need to do that, is to create an instrumental variable that will point at JP and that would control, test and control for endogeneity, model endogeneity, because there are two variables here in this model that influence JP only indirectly, and those are DM and SJ. So I need an instrumental variable that will control for the indirect influence of DM and SJ on JP. Um, and again, I should not just create links from DM and SJ directly to JP, because that could lead to that would be a different model, and that could lead to false positives. So I'll start with that. So I'll go to Explore, Analytic Composites, and Instrumental Variables, and I'll create an instrumental variable for JP based on DM and SJ. These would be my instruments. So as we can see, these instruments are correlated with JP, but they don't point at JP at the model. This creates a problem known as in-model endogeneity or endogeneity. So I address this problem by creating an instrumental variable and making it point at JP. So I'll create this variable. It will be created as an indicator. So I will then add this to my model. That's my IJP, instrumental variable for JP, and that will have this indicator. Now, since I want to assess this reciprocal relationship, I will remove it from the model. I need always to do that when I want to assess a reciprocal relationship, at least in the up to this version of WarpPLS version 8.0. So I will delete this direct link, and I will assume that there is a reciprocal relationship between JS and OC, which means that I will have to create more instrumental variables because before I create the instrumental variables to assess the reciprocal relationship proper as it is. And So if I assume that there is a reciprocal relationship between JS and OC, I am assuming that there is a link going this way and there is a link going this way. This means that there will be variation from SJ flowing indirectly to JS and from DM flowing indirectly to OC. So I need to control for that even before I assess my reciprocal relationship. So I'll have to create uh, instrumental variables in the same way that I created this instrumental variable here. So I will go to, again, the option, explore analytic composites and instrumental variables. And I will create one instrumental variable for JS to account for variation that flows from SJ. Again, I will not create a direct link between SJ and JS because that's not part of my model. My model uh, does not have that link at the population level. So I will create this instrumental variable to control for endogeneity. And again, there is variation from SJ that ends up in JS, and I can see this because of this standardized regression or correlation between those variables. So I will create that. And I'll create one for OC, but now we're not with SJ, but with variation coming from DM. So this is very low, but still I will control for that. So I will include those instrumental variables in my model. So that's IJS, instrumental variable for JS, and IOC, instrumental variable for OC. So I'm going to put them here. I'm going to make them point at the variables that they've been created for. Now we'll save my model and close. Now we'll perform my analysis. I need to perform my analysis because I need the software to estimate the the values, the scores for JS and OC with all of these control variables included before I estimate my reciprocal relationship. Okay, let me check my settings. Yes, I want these settings. So now I'm gonna assess now the reciprocal relationship. So I'm gonna go to Explore again, analytic composites and instrumental variables, and I will choose now reciprocal stochastic variation sharing to create my instrumental variables. I will create two instrumental variables, and I will assess or test the relationship between JS and OC. And these are the coefficients that the software is telling me um, should be the coefficients that I should get um, for my reciprocal relationship. So as we can see, there is a stronger path going from OC to JS and a weaker one, but still significant, going from JS to OC. So I will, and this accounts for the fact that endogeneity here seems to be significant because there is more variation flowing from Sj to Js because this path, this reciprocal path here going from OC to Js is stronger, as we can see here. So I will create my uh, instrumental variables for the reciprocal relationship. So I'll create one, then I'll create the other. I'll just use the names that the software is giving to them. Okay, then now I'm going to add those to the model. So I will call this one OC pointed at by JS. I'll use that indicator created by the software. And I will call this one IJS pointed at by OC. And so I have them here. And now I'm going to make them point to the variables that are indicated as being pointed at. So this one points at JS, so I'm going to create the link in that way. So this is a new uh, way of doing of creating the indicators starting in version 8.0 that makes it easier for users to come up with or assess reciprocal relationships. So this one is pointing at OC. So I will make it point to OC. Okay. So now I have everything in the model. And now I'm going to perform my analysis. So here's my model now with the reciprocal relationships entered. So it's around 0.44 going one way, 0.12 going the other. Um, this again controls for all of the variables. So this coefficient controls for possible endogeneity, which is accounted for this variable. It controls for this one as well. Now, let's say I got here and then I want to test whether there is a reciprocal relationship between these two variables because I see this coefficient seems strong. Typically, relationships are associated with strong correlations among the variables involved in the relationship. And for example, between JS and OC, if I look at the correlation among those two variables, JS and OC, it's here. So it's a strong correlation. There is also a strong correlation between JS and JP. It's actually even stronger. So it's reasonable to assume that this relationship here is also reciprocal. Now I know that the data was created so that there is only one reciprocal relationship in the model, which is this one between these two variables. But I can test to see if this one is reciprocal as well. Uh, the software should give me an answer that suggests that there is no reciprocal relationship. So, but I'll try. So what I'll do is I will go to uh, I'll change my model again, and I will remove this link. And I will go again to explore. So if I want to test if there is a reciprocal relationship between two variables, I need to remove the direct link, if there is any, between them. So I'm going to go to explore. I'm sorry, I need to redo the analysis because I need the latent variable scores to conduct this test. So now I'm going to go to explore, instrumental variable, reciprocal relationship. And now the one that I'm going to test is the one between JS and JP. So JS and JP. So the software is telling me that could not converge to a viable solution. Consider changing the model or revising your model. What the software is telling me is that what I'm trying to test here is essentially a model that has a reciprocal relationship. And the software is telling me that it cannot converge to a solution. So the software does have, the configuration here allows me to test um, a reciprocal relationship because both variables are endogenous. The variables that point at them are different, but the model that the software could not converge to a solution, which essentially means that the software cannot find a reciprocal relationship, cannot find a way for that reciprocal relationship to exist. And for it to really find a reciprocal relationship, the software has to assume that there is a link going this way and a link going that other way. And what the software will do is it will calculate the total effects of this variable, a variable that points at JP, and with the strongest association with JP. It will calculate the total effect of this variable on this one. And in doing so, it will estimate this path. But it may be that to calculate this total effect, the path may end up being greater than 1, which would be a non-viable solution. And that is what is causing the problem here. So generally speaking, if there is no reciprocal relationship, the software will indicate that. And this is a feature of the software in version 8.0 onwards. Future versions ideally would allow one to just create a reciprocal relationship link and then do the analysis directly without having to do all of this. Uh, but at the moment, that's what one has to do. So, what I have to do is then go back and add that link back to the model. I could do the same thing for this uh, relationship and see if it is reciprocal. Uh, but I would just add the relationship that existed before, redo my analysis, and this is the model with the reciprocal relationship. So I was able to test whether there was a reciprocal relationship, and that seems to be correct. Now, from a conceptual perspective, you might also expect that there is a reciprocal relationship because job satisfaction would increase organizational commitment, and that organizational commitment might increase job satisfaction as well. That's what the model is suggesting. Job satisfaction may also increase job performance in being a higher performance employee may also increase job satisfaction, but it may decrease job satisfaction a little bit because there will be other offers from other organizations if you are a high performing employee. So that positive and negative feedback loop can cancel each other out, and then this is why conceptually, it makes sense that there is a relationship going only in one direction between job satisfaction and job performance. So this concludes this video discussing uh, reciprocal relationships and how one could test multiple reciprocal relationships in one analysis.